Now, as we advance through this chapter, the examples are designed to get the student to think and not to simply react. Probability is a very dynamic discipline, and what I mean by that is the formulas and tools we use to determine a solution are only part of the process. The bigger challenge is determining what a particular problem may require. So you must be actively engaged in this scenario to arrive at a correct solution. Also, because many of the calculations will require extremely large values, we're going to use the scientific calculator to help process our workload. The calculator I like to use is the TI-30, and that's this one right here. You can tell a scientific calculator it'll have a couple of keys to it. One of them would be a squared key, also with a square root key. It should have a pi key and a logarithm key. I like the TI-30 series because it also has this key right here, PRB, and that stands for probability, and I'll show you how to use that key once we get into the example. So this example says, suppose at an NCAA Division III swimming and diving championship, the 100 freestyle event has 48 swimmers assigned to 6 heats. There are 8 lanes, which means there are 8 swimmers per heat. 4 of the 48 swimmers are from Kenyon College, that's in Gambier, Ohio, and 3 swimmers are from Denison University, that's in Granville, Ohio. Then says if lane and heat assignments are randomly chosen, and then we have these 3 questions here, A, B, and C. So a couple of things to point out. A heat is simply a portion of a competition. Since there are a limited number of lanes in a swimming pool, depending upon the number of entrants, the competition is divided into a series of heats to accommodate everyone. So that's why we have 48 swimmers here. There are 8 lanes to a pool, so there are going to be 6 heats. Also, we have 4 swimmers from Kenyon College and 3 swimmers from Denison. Now, for any probability that we have to calculate, it's always established as A over B. I'm going to put it right here. B, the denominator, that represents the sample space. That tells us how many possible outcomes there are for some probability experiment. And A up here, our numerator, that's the event that's in question. A is always a subset of B. So for letter A here, it says, what is the probability that 1 swimmer from Kenyon College and 2 swimmers from Denison University are assigned to the first heat of the event? So we're going to do this by hand first, and then we'll use our calculator. So the first thing we're going to do is we're going to find our sample space. That's our denominator, B. And that is we have 48 swimmers, and we're going to randomly select 8 of them. So that comes out to be 48, choose 8. That's how many ways we can choose 8 swimmers out of the 48. That's our sample space. Now our event. What's our event in question? Well, 1 of the swimmers has to be from Kenyon College. 2 of the swimmers have to be from Denison University. So if I have 4 swimmers from Kenyon, then I have 4 choose 1 from Kenyon. Since I have 3 swimmers from Denison, that's going to be 3 choose 2 from Denison. And don't forget, we have all the other lanes to fill. So that's going to be 41 choose 5 for all the other swimmers. So since there's 4 choose 1 ways to choose a swimmer from Kenyon, 3 choose 2 ways to choose 2 swimmers from Denison, and 41 choose 5 to get everybody else, how many ways are there altogether? Well, the fundamental counting principle says we simply multiply. So this right here, this ratio right here, represents the solution for A. Now, something to keep in mind is that since the event here is a subset of the sample space, then the values within the event have to tally up to equal what's in the sample space. And what I mean by that is the subscript n here, the number size, for each one of these combinations, when we add them together, has to equal to the number size of the combination in the sample space. 4 plus 3 plus 41 will equal 48. Same way for the selection, that's R, our R subscript, that's 1 plus 2 plus 5 has to equal to 8. So that's one way we could check to make sure that we're on the right track. So now we'll go ahead and we'll figure the sample space here. 48 choose 8, that's going to be 48 factorial. 48 minus 8 factorial, that's 40 factorial. And then 8 factorial. 40 factorial in the denominator will cancel out 40 in the numerator. That's going to leave us with 48 times 47 times 46 times 45 times 44 times 43 times 42 times 41. 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3, 2, and 1. Now we'll cancel out factors. We have 8, 8, and 6. There's 48. I have 3 times 2 times 1, that's 6, and 6 times 7, that's 42. I can do 5 goes into 45 9 times, and 4 goes into 44 11 times. So then for here, we have 47 times 46 times 9 times 11 times 43 times 41. For our event, for our numerator, 4 choose 1. Hopefully you know that that's 4. 3 choose 2. Hopefully you know that that's 3. But then 41 choose 5. That's going to be 41 factorial. 41 minus 5, that's 36 factorial. 5 factorial. 36 factorial in the denominator, cancel out for 36 in the numerator, leaving us with 41 times 40 times 39 times 38 times 37. 5 times 4 times 3, 2, and 1. 5 times 4 times 2, there's 40. And then 3 goes into 39 13 times. So then we have 41 times 13 times 38 times 37. And if we look again, we can see we have 41 here, and we have 41 here. And maybe the best we can do is we can take out 3 here, and this turns into 3. So now I could go ahead and use my calculator. Now when I enter this, I want to use parentheses because I want to be able to delineate between the numerator and the denominator. So I'm going to use parentheses here. And I'll start off with 4, that's right here, times 13 times 38. So all we're really doing is lightening our load a little bit, times 37. Close off that parenthesis. Then I'll divide, start with a parenthesis again, so I can put in my denominator here. 47 times 46 times 3 times 11 times 43. You can use your scroll keys here if you want to scroll back to make sure you got everything, but I think we did. So we'll hit enter. And we have approximately 0.0238, and we will go by 4 decimals as a decimal. Of course, we know that as 2.38%. So what is the probability that one swimmer from Kenyon College and two swimmers from Denison University are assigned to the first heat of the event? Approximately 2.38%. We'll do the same thing, except we'll use our calculator this time. So here is our PRB, our probability key, and if we click on it, these two menus come up. PRB here, that stands for probability, and RAND right here, that stands for random. Right now, the probability one is highlighted. That's the only one we're concerned with. And underneath that menu, we have 1, 2, 3. We have this here. Look at that. That's our permutation. That's N permutate R. This one here, this is N choose R. And right here is our factorial. So just to demonstrate it, I'll show you what we can do. I know that 5 factorial, that's 5 times 4 times 3 times 2 times 1, and that should be 120. I could also enter it as 5, go to my probability key, and you could either scroll down using the scroll keys and hit enter. There's my 5 factorial, hit enter again, there's 120. Or you could simply do 5, go to the probability key, and then just type in 3. And there we go, there's our 120. So for this ratio right here, I'm just going to type it in pretty much as we see it here, except I'm just going to lighten our load a little bit. I already know that 4 choose 1 is 4, so I'm just going to type in 4 times 3 choose 2. I know that to be 3. 4 times 3. It's the 41 choose 5 that I'm having trouble with. So I'm going to type it in as 41. Go to our probability key. Type in 2. So there's our choose. 41 choose 5. And as you can see right here, we have 4 times 3 times 41 choose 5. Hit enter. And that's 8,992,776. I'm then going to divide that by our sample space, by our denominator. So I'm just going to hit the division key. And the division has this ANS here. That stands for answer. So when you just go to an operator key and you just hit it, it's going to create an operation on the last answer that came up, and that's this value here. It's just a little bit of a shortcut. So I'm going to divide, and I'm going to type in 48, probability, choose 8, and hit enter. And there is our 2.38%. Now, it's always a good idea to know how to do this by hand and on the calculator. What happens is a lot of times when students know how to do it on the calculator, everything goes on the calculator. And when that happens, there's a lot going on in the calculator. Sometimes students get lost and they come up with a wrong solution and they don't know what they did wrong. So it's always best maybe to do them both ways until you get very confident on what's going on. And I'll show you how we can do that. So for letter B, it says, what is the probability that a swimmer from Kenyon College is assigned to the first 4 heats? So for the first heat, we've got these 48 swimmers. We're going to choose 8 of them. What's the probability that one of the swimmers is from Kenyon College? Then we go on to the second heat. We're going to choose the swimmers for the second heat. What's the probability that there's a swimmer from Kenyon College for that heat? And then, of course, for the third heat and the fourth heat. That's the idea. So for the first heat here, I'm just going to put a 1 right there. We're going to determine our sample space, our denominator. We have 48 swimmers. We want to choose 8, so that's 48 choose 8. For our event, we want one of those swimmers. What is the probability that one of the swimmers is from Kenyon College? There are 4 to choose from, so that's 4 choose 1. And then we have all the other lanes to fill. So that's going to be 44, choose 7. Again, our subscripts 4 and 44 should match the subscript of the sample space. And our chosen, our R's, 1 and 7 should match 8. Now I'm going to use my calculator to go ahead and plug this in. But this is 90% of the work right here. So now I'm going to do hopefully 4 choose 1. We know that to be 4 times 44. Probability choose 7. Then I'm going to divide. And I'm going to do 48. Choose 8. And that's approximately 0.4062. So the probability for the first heat, one of the swimmers is from Kenyon, that's 40.62% chance. That's for heat 1. Heat 2, for my sample space, now don't forget, we already had 8 swimmers swim in the first heat. I have fewer swimmers, so this is going to be 40 choose 8. I already had a Kenyon college swimmer in the first heat. I'm going to have fewer Kenyon college swimmers, so this is going to be 3 choose 1. And of course, I have fewer swimmers to fill all the other lanes. This is going to be 37 choose 7. And again, 3 and 37, that's 40. And 1 and 7 is 8. 3 choose 1, that's 3 times 37. Choose 7. Divide that by 40. Choose 8. So this is approximately 40.16%. That's for heat 2. We continue on to heat 3. So hopefully you can see what the problem is asking, and we have to be able to build our scenario from there before we can use our calculator. Our calculator will work provided that we built our scenario properly. We built this ratio to reflect what's going on. Again, we have 8 less swimmers. So our sample space, our denominator, is now going to be 32. Choose 8. We have one less swimmer for Kenyon. We now have 2 choose 1. We have 8 fewer swimmers to choose from here. This is going to be 30 choose 7. Two choose 1, that's 2. I'm going to do 2 times 30. Choose 7. I'm going to divide that by 32. Choose 8. This is approximately 0.3871. And finally, for the fourth heat, we have 4 heats. Again, I have 8 less swimmers. So this is going to be 24. Choose 8. I have 1 less Kenyon swimmer. That's going to be 1. Choose 1. Of course, 7 fewer swimmers here. That's going to be 23. Choose 7. Again, you could always check 1 and 23. That's 24. And 1 and 7. That's 8. 1 choose 1. You know that as 1. You don't necessarily have to type that in, but we'll do it anyways. 1 times 23. Choose 7. We'll divide 24. Choose 8. And look at that. 0.333 and 3. So the idea is, if there's so many ways for this to occur for the first heat, so many ways for this to occur for the second heat, so many ways for this to occur for the third heat, and so many ways for the fourth heat to occur, How many ways can this occur? That would be letter B. That's what we're asking for. What's the probability that this will occur? We multiply. Using the fundamental counting principle, you just multiply. So we're going to multiply all of this. So I'll do 0.4062. That's this right here. Times 0.4016 times 0.3871 times 0.3333. Hit enter, and that's approximately 2.1%. So much more convenient using our calculator than having to do this by hand. However, the key is to be able to build each one of these ratios properly. So you really have to read these problems to make sure you understand what is occurring before we can go ahead and apply the mathematics. Now for letter C, it says, what is the probability that the swimmer from Kenyon College assigned to the 4th heat is swimming in the 3rd lane? So now you have a Kenyon College swimmer who's assigned to the 4th heat. What's the probability he's going to be swimming in the 3rd lane? Well, his probability of swimming in the 3rd lane is the same as any of the other swimmers swimming in that heat. There are 8 swimmers in a heat. What's the probability that the Kenyon College swimmer is assigned to the 3rd lane? That's simply 1 out of 8, and 1 out of 8 is 12.5%. And there's your introduction to using combinations on your calculator.